18C. Number 1. Shown below is the probability histogram for the sum of 15 draws from the box. What numbers go in the blanks? Well, that's hard. 5 and 8, just count it up. Which is a more likely value of the sum, 3 or 8? So this is a probability histogram. This is what we expect to happen. And is it possible to get 15? Yeah, but it's very unlikely. It looks like 0% over there. So the answer is 3. How come? The box is taller at 3 than it is at 8. Number 5, 25 draws are made at random with replacement from each of the boxes, 0, 1, 9 zeros and a 1, and 24 zeros and a 1. The probability histogram for the sums are shown below in scrambled order. Match the histogram with the boxes. So number 1 would have to be B. Okay. How do we know that number 1 is B? There are more zeros than ones, so we would expect the curve to slide towards 0. Okay. And then A has to be number 2 because it's totally symmetric, 1, 0, and 1, 1. And 3 is C, which is basically the same shape as B, only shifted further to the left. Now, if I made a lot more draws, would all of these curves end up looking bell-shaped? If I did, let's say, 100,000 draws, would they all be roughly the same shape? Yeah, they would have a different value, but the shape would be the same. So when you're adding up numbers on a dice, it doesn't matter what the numbers on the dice are. Eventually, it will look like a normal curve. But the further away the box is from being normal, the longer it's going to take for the curve to be normal. And so this is just a simulation with 25 draws, which is why 1 and 3 don't look very normal. Eventually they will be, but 25 is not enough to make that happen. Number 6. Shown below are the probability histograms for the sum of 100, 400, and 900 draws. Which histogram is which? All of them are oh, never mind. Sorry, I got it backwards. So 100 draws is going to look like 1, 400 draws, 2, and 900, 3. Okay. And 7. This exercise refers to the top panel of figure 9 on page 322, which shows the probability histogram for 25 draws from the box 1 to 9. The chance that the sum is 100 equals either the area between 99.5 and 100.5 under the probability histogram, or is it the area under the normal curve between 99.5 in standard units and 100.5 in standard units? Which one is it? So let's look. We don't have 100 draws. Oh no, 25 draws. Okay. So we're looking at the top graph on 322. So you see two x-axes. One is the value of the sum, listed from 40 to 160, and one is the standard units between -3 and 3. So do we want to shade from 99.5 to 100.5 on the top x-axis or the bottom x-axis? It's got to be the top one. Okay? So in standard units, you wouldn't use the sum, you would use the SE. right? That you would use a z-score basically. So the question is asking, do we shade using a z-score of 99.5 to 100.5, or a sum of 99.5 and 100.5? Well, you would use the sum. If it was z-score, then it would be something like negative 0.01 to 0.01 or something like that. All right.